So let's start this problem by making a diagram. They move into a house and they have a yard that is not fenced in. So here would be the yard, and the previous owner gave them 300 feet of fencing to use to enclose part of their backyard. So that if you were going to enclose part of the backyard, it would presumably look something like this. Now you're making some assumptions, and the first assumption is that the yard is rectangular. And you are also assuming that the house is long enough to cover part of the entire one side. So it's not looking like this. This would be a different problem altogether because you would need this little extra. So we're making the problem a little bit simpler by assuming a simple rectangle and the house will cover one side of the yard. So you need the fencing, the 300, to go all the way around here in blue, 300 feet. And so they give you the formula for the area, but I would like to generate that formula with you together. So we're going to declare a variable, and we don't know the dimensions of the yard, so I'm going to let x be this dimension. And that means if it's rectangular, this is also going to be an x. So if I've got 300 feet of fencing, then I know that this remaining piece has got to be 300 feet minus the 2x's that we've already used for the side. So I have now an expression for the length and the width of the yard that needs to be fenced. So area equals length times width, and the area is the length, which is 300 minus 2x, and the width, which is x. Now in this formula, notice they've written it the other way around, but remember multiplication, that should be 300 there, 300 minus 2x, same thing. So now let's answer the question. The question is to find the maximum area. So if I get rid of this bracket by multiplying the x into the bracket, I can see maybe a little bit more easily that this is a quadratic, which means it's going to be a parabola. And because of this negative, it's going to be a parabola facing downwards. So I can need to find the vertex. And I know you can find the vertex using the formula x equals negative b over 2a. But I'd also want to now just give a little bit of time and practice to completing the square. So I'm going to rearrange this so that the x squared is first. I am going to factor out the negative 2, and that leaves me with x squared minus 150. X, and now I'm going to complete the square. So the way I do that is I take 150 and I divide it by 2. So what I'm doing there is taking this number here, 150, dividing it by 2, and then I'm going to square it. So that's 75, and then I'm going to square it, and that's the number that's going to be added and subtracted. So that's plus 5,625 minus 5,625. Now when I'm going to factor, I only need the first 3 terms to factor, and this one gets kicked out of the bracket. So my equation then becomes a equals negative 2 x squared minus 150x plus 5,625. And that's going to be plus, a negative times a negative is a positive, 11,250. Now factoring the bracket, I get x minus 75 times x minus 75, so I write it as x minus 75 squared plus 11,250. So that tells me that the vertex is at an x value of 75, because it's moved to the right 75, and up 11,250. So the question is, determine the maximum area. The maximum area is the y value, the height. So the maximum area is 11,250 feet squared.